Hello, my data firm. Welcome to my channel. This is Henry, your favorite data engineer. In today's video, we're going to look at how to create CTEs, that is called Common Table Expressions in SQL or SQL. That's what's called Common Table Expressions, CTEs. In PySpark, it's called DataFrames, and DataFrames simply a subset of a major source of table, right? And in Spark SQL, it's still called CTE or Common Table Expression because you're still going to write a SQL function or a SQL code to run it. And what are the importance of creating a CTE? CTEs are simply creating a subset of the major source table to help you run simple analysis or to help you create complex analysis as well, because you need this simple extracted table from the major table in order to join with other tables and make relevant meaning or relevant analysis from them. These are also created in data pipelines. As data engineers, we write a lot of CTEs. It can get so complex, but let's look at something simple to help you begin your journey and to help you understand what CTEs are simply are. Let's start right now. Great. Okay, so let's take a look at our data to begin with, so we have a good understanding of what kind of data we'll be using to create this CTE. So in the Databricks free edition, they are already pre-uploaded tables that we can make use of. In this particular video, we'll be making use of a catalog called Big House. And so let's take a look, and we have some tables in this schema. So what we want to focus on is the sales transaction. So let's go to sales transaction table and take a look at the column and some sample data. So let's look at the column first. We have transaction ID, we have customer ID, we have franchise, we have data time, date time, product, quantity, unit price, total price, payment method, and card number. Let's take a look at the sample data. Let's start our compute resource or serverless and wait for it to begin. And then it's already loading. It's beginning, starting up, right? If it start up, we will get a notification. Let's see, let's go back to the table, take a look. All right, I think the compute has started, so we should see some data. Great. This is what we have: transaction ID, customer ID, franchise, date time, product, quantity, unit price, total price, payment method, and card number. Great. So we're going to start with SQL. And in this SQL, we're going to create a logic where we create a CTE and only pick some specific column. Not every column here might be relevant for this scenario. The columns that we'll be using are transaction ID, product, and payment method. And in this logic, what we do is we create a CTE, and based off of that CTE with these three columns, we're going to filter out and just say we want data set for payment method that were made with Visa. That is a simple logic we'll be making use of. We want payment methods that were made using Visa. That will be the CTE we'll use to filter this. So to begin with, let's start writing our SQL code. We go back and start a query, and then we name this SQL CTE. SQL CTE. Great. So we've been able to name our SQL editor SQL CTE. Now let's take a look at a table, right, using query, right? So we already know writing a query, you need to determine, or you tell the query engine where you are picking your data from. So the first thing is we're telling the SQL, go to this table. That is what it means. So from let's go back to the table and copy the name, and we know in data breaks. Naming a table is the catalog name, the schema, and then followed by the table name. But to make things easier, we just copy this and then go back and paste. So this is the table name, right? The catalog name, which is samples, the schema, bake house, the catalog name, which is samples, the schema, which is bake house, then the table name, which is sales transactions. So from sales transactions, let's select, based on our logic, what we need is transaction ID, comma, then we need product, comma, then we need payment method. Great. So let's run this. Let's start the computer. I think the compute went off. Let's start it, and then the output should reflect in here. Column variable, sorry, payment method is together, so we need to put it together and then run it again. This time around we got the data. Great. So this is the table that we have, the columns that we need for this CTE. Right, so these are the columns that we need for this CTE, implementing this CTE. We only need 3 columns: transaction ID, products, and payment method. Now looking at this, we need to indentation. We need to implement indentation properly. Indentation is just about how you arrange the data for it to look readable, maintainable, and understandable by other data analysts or data engineers, so that in the event you are not part of that team anymore, anybody can take the code and understand what you're trying to create or the code you wrote. So to do this, we just want to arrange it properly so that it makes much more meaning and much more sense and looks much more beautiful. To do that, let's highlight the columns that we selected and use the tab key, and then we shift it a little bit inside, right? So this way. And so this is proper. We are now saying from this table, what did we select? We selected transaction ID, product, and payment method. Great. So we can see that from this major table, which has so many columns, all we did was to just select some specific columns that were relevant to our scenario. This is where we are going to implement the CTE. And to do a CTE, as I said, is simply creating a subset or extracting some specific part of a major table and converting it to look like another table for yourself. But in this case, we don't store it. It is just a temporary table that is being created. Common table expression is just a temporary table or an expression that is done, and then so that you can reuse it within that same code base, right? So with these 3 columns, we are going to convert them into a CTE, which we can call later on within the code, right? To do this, there is a function we use, or we use the with logic, right? We call the with. So what we do is with. Now we need to give this table a name that we call it, right? Previously, the original table is called sales transactions, but with these 3 extracts that we made from the original, we are just going to call it sales CTE, and that is good. So we call it sales CTE with sales CTE. Now we need to attribute this name to a table that a temporary table or simple logic that we did, right? So we are going to say that this table should be called this, right? Should be assigned this. So the new name is this. So sales CTE as into bracket, you put it in, or in close, open and close bracket this way. So now this is our CTE, and let's make the indentation much more better. So let's push it in this way. Great. So now we know this whole table is now called sales CTE, right? So that is how you create the first CTE. Always, a CTE should always begin with a with, right? The with, and then the CTE name, and the assigned query or the columns that you want. Right. Now let's rename this table and make it much more easier. And that's what we did previously in our previous video. So let's give this name as trans ID this way, and change this to as payment this way. So it becomes easier so that we don't type so long. We don't use a lot of typing. And it's also, you can convert it to names that are easier for the data analyst or whoever would look at the data to understand what you're trying to say, because it's different from having a programmer code his table names and then analysts need to convert it, or data engineer need to convert it to make it understandable by the end user, which are the business people, right? So we rename this way. Then we have, in this case, now this is a CTE we've created, and the CTE name is sales CTE. Now let's move on to calling this sales CTE, this column, and now we filter based on the FISA, the logic we did. So now what we do is, from, in this case, we are not going to call the original table, we are just going to call the sales CTE this way. Right. Select from this table, select, what are we selecting? We're now going to use the new names. Select trans ID, comma, product, comma, pay underscore mint. Great. So this is another CTE, the final CTE, the final select, right? The final select in the CTE. Now let's apply our logic, where payment, pay underscore mint equal quotation mark FISA this way. Let's run it. This should filter out the end result. This final select to filter out from this CTE that we created all payments that are just from FISA card, right? So let's run the code, run all, and the engine has run. Great. So we have this, and so this is what we had. Nice. So we can see that we already we've been able to create a CTE, which is this, and we created a final select based off of that CTE to implement our where clause. This CTE can be called in any part of this code base, again, for reusable, for it to be reused in any aspect. If it's a complex CTE or a complex task, you can recall the CTE and use it anywhere else within this code editor. Great. Now let's move on to doing this same CTE in PySpark. In PySpark, it is not called a CTE, but it has the same logic as SQL, which is CTE. But in PySpark, it's just simply creating data frames, right? You create a temporary data frame, and then you use the temporary data frame for whatever you choose to use it for, right? And you can use it multiple times within that same code base, right? And that is what we call data frame in PySpark. So let's create a notebook to use PySpark. Let's create a notebook and name the notebook CTE underscore PySpark. Great, this way. And we already know in PySpark, for you to be able to use this, you first need to import the models that will enable us to use the Spark engine or to use the SQL functions in PySpark. So to do that, let's import the models, right? They are just default built in, so you don't need to install anything for this. Databricks makes that already, and you don't need to start a session because automatically Databricks starts the section for you. If you were on your local host, the Jupyter Notebook, you would have to initiate a session by yourself. But because we are using free edition, Databricks free edition, the session is already initiated, so you don't need to create anything. So you just call the model from PySpark.sql.functions import star. Now, great. So we've been able to import the SQL functions from PySpark, so we can use it now in our data frame. Now let's create a data frame from the original table, right? To do that, to create a simple data frame, it's just a matter of giving the data frame a name, right? You just determine or define any name that is much understandable by you. So in my case, in this case, I just want to have it sales equal. Now you call Spark dot read dot. So we know we are going to read from an existing table. This is a table. So from a table, this table. So read dot table, open bracket, quotation marks, and then you paste the table name just as we have it, right? So we've been able to create a data frame. So this is a data frame. If we run this, we should see a data frame having all these columns that were in the original table from the source, right? So let's run this and just take a look at the data frame that has been created, right? So it should have the data frame, the columns that were in originally this table, right? So that is how to create a data frame. You can call it any name, but when you start a data frame, you need to initiate the Spark, right? Spark, you are using PySpark, so you need to initiate the PySpark to read it. In that case, you are telling Spark to go and read that table for you. So this is the data frame. You can see it already gave it a name, DataFrame, right? With the various columns, 8 field, other fields, right? So this is it. This is how it looks. Great. Now from this data frame, we don't need every column here. So what we can do is to just initiate the select function on it, right? We just select the columns that are relevant to us in this case. So we continue with dot select, open bracket and close, come down, and then in this case what we need is transaction ID, right? What we can do is put it in quotation marks, right, this way. Then if let's use the column this way, and sorry, pin and close this way, comma, column, pin, close, and then we're telling Spark that go and pick a column from this table. That's all. And moreover, these tables, if you go to the original, they are just a matter of columns, just like Excel. We have rows and columns, right? And you're just telling PySpark pick these columns, this column, this column. So this call here is just a function that is inbuilt, and I'm using it to tell PySpark that go and pick this column for me, right? So it's simple as that. It's just a matter of saying go and pick this column. Yeah, so we need that, and we need product. The final column that we need is payments method. Great. So now we have filtered down, or we have selected a specific columns that we need. If we run it, it should pick out columns that we don't need and show only these columns that are relevant to us. Great. So there's it. And we can even take a look at the data by including a new line, a new row in here, and display sales, the name of the data frame. So we want to see the content. If you want to see the content of the data, you use the display.sales or display.data frame name, display into bracket data frame name. Yeah. So let's run this, and what we should see, you should just be limited to these fields that we have specified, right? And we can see the compute is running, right, and making the various calls that we need. Yeah, so we have this, data. Great. Now let's move on to applying our where clause and then filtering out only payment type that are for Visa. That's the interest that we have, right? And so if we look at this is the first data frame that is being created, and that is what in SQL we call CTE. So this is the first CTE, in code CTE, which is a data frame that has been created for us using PySpark, which we call sales. Now let's go to a new line, and then you create a new data frame kind of like a CTE and then apply the where clause in there. So this time around we say sales final, right, equal sales dot select. So now we're calling from this data frame, not from the original table anymore. We are no more initiating spark.read because we've already done that, and Spark is already aware of this table. So select to bracket. You can apply the call again, right? Column, and we have transaction ID. But from the previous SQL that we did, we converted this into a different name, right? So in this case, we'll use the alias. It's just renaming the column to a name that is more understandable by us. So alias to bracket quotation marks. We called it tran ID. Great. Comma. We have column, and then we have product. We did not change the name of this, so we maintain it. Column, pick the payment method, right? And we named this alias. We named it pay underscore mint. This way. This is what we got. Then we implement the where clause dot. So in PySpark, if you want to implement it, you use an object this way, dot where this select tables, all this data, where, so first filter where bracket, we have, you can do call bracket transaction ID equal visa. Here trans ID sorry where now we create a data frame where transaction ID equal visa. Yep. So this is how to implement equal in PySpark, right? Those are the inequalities. Now let's display, and we should expect to see sales underscore final. So we should expect to see filtered out only sales final. Display sales final. Oh, sorry, we're using the wrong. So this should be payment method. Oh, this is why we're making the mistake, right? Debugging, this is what we call debugging. So you're trying to debug what you're doing, right? So let's run. Now let's run this. Saying parameter name payment method cannot be resolved. Okay, so we renamed it to this, and this should work now. Yeah, sure. So because we renamed this to payments, we need to use the alias, the new name. Yeah, PySpark wasn't aware of the previous name we were using. Great. So this is how you do it. So this is the inequality you use. Then you need to call this. You create this column. You rename it. We create an alias, and then we create an alias for this as well. And then we call the visa in here, and then we have the data frame to display this. So this is what we have. Great. So pretty easy, right? And you are faced with debugging sometimes, and that's what we call debugging, trying to find what happened, right? And so good. This is PySpark, how to create data frames, right? These are subsets of the major source of table that you have, and then applying a logic on it to get the exact business logic that you want. So great. Let's move on to creating Spark SQL. With Spark SQL, what happens is you're going to use the same logic as you created in SQL this way, this one, right? You're going to use this same logic, but in this time around, you're going to wrap it up using the Spark engine. That is what it is. You're going to write the same SQL function or SQL code. You're going to write the same SQL code, but this time I use the Spark engine to run it. And this makes use of Spark's distributed compute or distributed resources to run it. Workers to use the workers to run it, right? So let's move on to that. Let's create a notebook, a new notebook. Then name it Spark underscore SQL underscore CTE. Great. We have this notebook. Let's import the models from, just as we did from PySpark, from PySpark dot SQL dot functions import start this way. Yeah. Now let's create a data frame. That is what we call like a CTE, right? That's what it's called in PySpark, right? Let's create it. But in this case, we're going to create just one CTE, right? We're going to create just one CTE. Okay. We're going to create just one CTE. And with this one CTE or one data frame, in this case, one data frame, it is going to include all the logics that we have, because we're going to create a SQL. We're going to write a SQL in it, and in the SQL, that is where we have the CTE itself to run, right? But we're just going to use Spark to run the SQL, and that's why it's called Spark SQL. You are writing a SQL code by using the Spark engine to run it. You are leveraging the Spark engine to run it. So to do that, let's create a data frame. Sales equal Spark dot SQL. So with this, you're telling Spark, get ready, I'm going to write a SQL code. So I'll leverage your Spark compute or Spark engine or Spark workers to run my SQL code. That's all you're telling Spark, right? So open bracket, and we use quotation mark, 3 of it opening and 3 closing. So 1, 2, 3 this way. Now it comes this way, and this is it. So now within these two, that is where we write our SQL code. So let's write the SQL code. So we know to begin with, we start from and then a table name. So we need to grab the table name, this. Great. We need to select and then use our indentation. Select transaction ID, comma, product, comma, and payment method. This is the first code we have, and you can see this is the same SQL we wrote in our first SQL code that we used to create a CTE. It's the same thing we do here. So now we need to convert this into CTE, right? We need to convert this into CTE. You start with a wait function, wait Spark SQL Spark CTE. Let's give it Spark CTE as bracket open. Let's go and close it at the end, and ensure that the indentation matches with where the width function is, because the whole function, the whole code is for the width and for the new CTE. So you close it in here. Great. So this is the first CTE. We've created a CTE, right? We have this CTE. Now from this CTE, we implement our logics and our where function, right? So from Spark underscore CTE, select indentation transaction ID, and we remember we renamed this, so as trans ID this way. Then we select the product, comma, payment method as well. We rename this as well as pay underscore mint this way. Now this is the final select that we have in here. Now let's implement our where clause. Where we have payment method equal visa this way, right? And so this is the CTE, this is the Spark SQL we have, right? So this whole thing becomes a data frame called sales. When we run this should create a data frame with only these filtered columns, right? And renaming them to this. So let's run this and see and take a look at the data frame, right? Data frame is created. So let's see. So we have this, so you can see with these new names that we have, this is it. Great. So let's display the results and ensure that the visa filtering was applied. Display, the name is sales, so sales. Let's run this and see what we have, and we should see that this has filtered out only data payment method that it was used with visa. Great. So we can see we have all the payments that were done with visa, pretty much the same result. Yeah, so that is how you can create. That is it for this video, and I hope you learned something new. What we did was to create a CTE, a simple CTE in SQL, and as well as creating the same using PySpark. By this time around, it's called DataFrame in PySpark, as well as combination of PySpark with SQL, which we created a data frame with SQL having the CTE within it, right? I hope you learned something. Subscribe to my video, to my channel. Subscribe to my channel to enjoy more videos like this, and also to reach more people who would love to learn from how to code in SQL, PySpark, and Spark SQL. And we'll be coming with more projects, more hands-on projects, which are more tuned towards data engineers and data analysts. To become a data engineer or data analyst, follow my channel, and we'll make you a good data engineer. Thank you. Bye-bye for now.